Alright, hi and welcome you guys. Today we'll be starting second semester with inverse variation, which leads us directly into the next big idea of where does x go, how do we graph it, and how do we work with it. But this actually comes from the idea of inverse variation, this next chapter, and how we work with that. And so what we're going to learn about first is inverse variation. So let's get a good color. Let's go red. Inverse variation. So whenever you see that y has an inverse variation relationship with x, and you don't even need the relationship part, it is inverse related with x. Write out these two equations to help you solve. Okay, y equals k over x and y times x equals k. Now understand that k is our constant. Okay, and as you can see in the forthcoming ones, k will always be the constant of variation. Okay, so as long as we understand that, we should be good. It's the same as direct variation. Okay, all right. So whenever you see an inverse relationship with x, okay, if you remember your steps from direct relationships, first you would go y times x equals k to get the constant of variation, and then you would plug in k to this equation and then solve for either x or y to figure out the other relationship. Now, just so you know, in the inverse variation relationship, as one goes up, the other one has to go down, okay, and vice versa. If the first one goes down, the second one has to go up. Now, if you look at the relationship within the fraction, this is a whole number over 1, okay, and this is just x. So as x gets bigger in the fraction part, y has to be smaller because we're dividing by a bigger number. And when you divide a constant by a bigger number, it becomes smaller in actual value in the decimal realm, okay? All right, now combined variations. Now that we know two different types of variations, combined variations and joint variations are actually just going to be what happens when you do multiple variations in one problem. So for example, this first one's going to be jointly. So whenever you see that y varies jointly with x and z, it's just like a direct variation relationship. Y equals k times x times z, and y divided by x times z equals k. So remember, these two are the two equations you're going to need to use when you see jointly with two other variables. Now, can we add more variables to the end here? Yes. That just makes this a little bit longer, okay? But that just also makes this a little bit longer too, and it doesn't change too much. So when it varies jointly, it's like a direct variation type relationship. Okay, now can we combine jointly and inversely? Heck yeah. So whenever you see that y varies jointly, now these are just examples from here on out of these are all combined variations. When you combine inverse, jointly, direct, all of those ones together. Okay. Now also, you could also, and I forgot to mention this, you could also have like squares on these numbers. So you could have x squared and w to the third. That just changes the value in here. So we'll take a look at that with this one on the bottom. But for now, whenever you see that y varies jointly with x and w and inversely with z, so you would write it out as y equals k times x times w divided by z, because z is the inverse and then jointly is the x and w. Okay, so that's more than two direct variations and one inverse. Okay, and then here's the problem you set up, and obviously, basically we're just solving a literal equation for k right here from this one. But I tell students in the beginning, just write out both equations because it's going to make your job so much easier when you're writing out what you know, what you don't know, and what you need to find. Okay, all right, wherever you might see that y varies directly with x and inversely with the product wz, and this is how you say like kind of jointly with inverse variation, you're inverse with the product wz. So you would have x up top because that's the direct variation, and then wz on the bottom because that's the inverse variation, okay? And then here's the second problem, you need to find the constant, all right? Alright, so here's the type of problem where y varies directly with x squared and inversely with z cubed. Okay, so directly, first off, we're going to just have y equals kx squared. That's going to be the top portion. And then our bottom portion is going to be the z cubed. And voila, we have our problem set up. Now, we don't stop there. We have the two problems set up. So we're going to have y times z cubed, okay? And then we're going to divide that by x squared to get the variation problem. I'm sorry, the constant of variation. Geez Louise, you think I just learned to speak math today just by what I just said, okay? So here's a problem. If y equals 3 when x equals 7 and z equals 5, what does y equal if x equals 10 and z equals 2? So this is actually two problems in one. So this first part right up here is asking us to find the constant of variation. Okay, so if we find the constant of variation, we should be good and set and ready to go. Okay, so first off, that information is going to go into here. We're going to find k, and then when we find k, we're going to plug it into here and finish off the rest of the problem. So we plug in everything. So 3 times 5 cubed is going to be up top over, oh, jeez, trying to get that line going, over x squared, which is going to be 7 squared, okay, and this is going to be equal to k. Okay, now this is going to be a messy problem, just work with it here. So that's going to be 3 times 125, that's going to be on top, divided by 49. Okay, and that's going to turn into 375 over 49. Okay, so that's my constant variation. That is a messy fraction, but it actually helps out when I'm trying to solve for the new problem of what y is going to be. So y equals 375 over 49 times x squared. Okay, so we set up the problem. And like I said earlier, you can definitely have x squares and z cubes in here and stuff, or you know, something like that. Accidentally press the 1 a bunch. Okay, so voila, we have our problem set up. Now, what the second part, we are going to use the second piece of information. What does y equal if x is 10 and z is 2? So we plug in a 10 here, we plug in a 2 here, and then we solve. Okay, now 375 divided by 49 times 10 squared, which is 100. I'm just going to write that out because we all know that part. And it's going to be over z cubed, which is going to be 8. Okay. All right, so this is going to be 37,500 over 49 is going to be on top. Over 8. Okay, now what we can do is just, and you're going to have to start getting used to this, you can multiply it by 1/8 to get rid of the 8 down here. Okay, and so can we get this to be a nice little fraction? It's not going to be the nicest fraction in the world, but it's actually going to be something pretty nice. Let me check on my calculator. 49 times 8, 392. Okay, and then we check our calculator, 3,000 divided by 392. And we reduce this the best we can, and you should get 9375 over 98. Voila. Magnifique is what they would say in France. Okay? All right. Now, in France, just so you know, little side note, they don't give out perfect scores over there. Like, if they were scoring out of 20, you would always get like a 19. There's no such thing as perfect over there. So this would be a 19 job right here. Okay? I'd probably be a 20, but you know, that's just the American way of always wanting to be perfect. Okay, but anyways, that's how you do direct or inverse variation and joint and combined variation. So once again, this is we learned inverse variation, which is going to have the variable on the bottom in the inverse variation relationship. And when we have two or more direct or inverse relationships, that is actually going to be what is called a combined variation. Okay, and as you can see, it's not that scary. It does get us a fraction that's pretty ugly looking, but at least we know the exact value. Okay, that's it. I will talk to you guys later about more inverse relationships. Bye.